Hi. Today we're going to go over absolute value functions. Absolute value functions are a pretty interesting concept, just like absolute value is, and they come with their own little unique flares and additions. Today we're going to go over their basics, how to work with them, and even how to graph them. So, first of all, let's get started with and ground ourselves in what an absolute value is, right? It's these two bars. And the idea is if we put any number in here, we're going to get the positive or non-negative version of that number, right? So if I put in 4, I'll get 4. And if I put in negative 4, I will also get 4, right? I will never get a negative number with an absolute value. But I can get 0. If I put in, let's say, 4 minus 4, which will simplify out to 0, I will get 0. That is allowed. I can get that. But if I put in, 4 minus 5, which would get me negative 1, my output would be 1, since I can't have a negative number. Basically, anything inside it will, when it's outputted, become positive, or at least non-negative. So that's the basics of absolute value, but how do they work as functions? Well, we denote them a lot, similar to regular functions, where we have our function name and indication of where the input is, the actual input, then what I'm supposed to do for that input right here, right? So this is the most basic version of an absolute value function, but they can be a lot more complicated. We can something have like f of x equals 3 times x plus 6 minus 2, right? Pretty complicated, but that still is an absolute value function. This is just a long series of instructions that tells me what to do for every single input x. Now, we can do the same things to absolute value functions as we can for regular functions, which of course means that we can graph absolute value functions. Now, their graphs are pretty similar to regular functions, except for some kind of noticeable differences. I'll start off with graphing just the standard absolute value of x. And to figure out its general shape, I'm going to plot some points. Let's say I want to graph 0, absolute value of 0 is 0. Let's say 1, absolute value of 1 is 1. 2, absolute value of 2 is 2. So it's starting to look like, on this side, it's just a straight line, right? It's sort of like y equals x for this, right? But what if I equal negative numbers? I plug in negative 1, I get 1. I plug in negative 2, I get 2. So I really just get a whole bunch of positive numbers. And on this side, it's like I'm graphing y equals negative x. Right? But notice, I stop. I come to a minimum at 0. I can never be negative, so I'm stuck meeting right at the middle at 0, 0. So it really just looks like two straight lines that I jam together and then cut off at the origin, or 0, 0. And the funny and particularly lucky thing is that when you're asked to graph these absolute value functions, you can follow the same general pattern that we use to graph quadratic functions. If you haven't seen my quadratic function video, I recommend you see it. But in this case, we can use the same general rules that we apply to them. So let's say we have an absolute, this is a general absolute value function like this, right? Some number a, absolute value of x minus some number h plus k. All right? Now, we will meet, those two lines will touch at the point h, k. And these two numbers together tell us how far we'll be shifting the graph, right? This h will determine how far we're shifting the graph horizontally. All right, so if this was x minus 3, that would mean we're shifting the graph 3 units to the right. So something like, this, for instance. If this was x plus 3, that means we were shifting it 3 units to the left. So something like this. This k refers to how we're shifting it vertically. So if this was 2 or 3 or 4, that means we'd be shifting it up 2 or 3 or 4. So we'd move all of our points up by 2 or 3 or however many number. If it was negative, we'd be moving it down by that corresponding number. We move all the points down. This a here is interesting in that it tells us how far the graph stretches vertically. And its sign will say if it stretches up or down. So let's get to this, right? So if this was negative, right? If we had something like, f equals negative x, that would just mean, within my table of values, instead of having it all be positive, it would all be negative. Because absolute value of x outputs only positives. But this negative sign here makes sure all those positive turn straight to negatives. So I'd have something looking like this, right? Where it's just 2 straight lines that go down for infinity, right? And what about, these values, these a's? The a value itself, if we take the absolute value of a, that refers to what we call the slope of the absolute value. All right, so imagine I'm graphing let's just say 2 absolute value of x. Right? What's that going to look like? So they're going to have 0, 0. But I plug in 1, I'm going to get 2. I plug in 2, I get 4. And I plug in negative 1, I also get 2. And negative 2, and I'll also get 4. So we'll have something like where my slope will just be steeper. So just like how we deal with slopes when we're graphing lines using y equals mx plus b, right? This right here refers to our slope. And just like if we were graphing, a higher value greater than 1 means a steeper slope. And a lower value, less than 1, like 1/2 or 1/3, means a less steep slope. And as you can see, those rules for absolute value functions are pretty similar to those for quadratic functions, and there's even an overlap with linear functions in terms of the slope. So all in all, not too bad at all, and they're pretty easy to master once you really get the hang of it. So I hope this video helped, and I hope you have a great day.